a cline, actually a gradual gradation of lighter and lighter skin tone the further away from the equator you get. So the higher the latitude, the darker or the lighter the skin, typically. Why is that? Well, UV radiation helps to synthesize vitamin D. And if you don't have it, especially as a child, if you don't have vitamin D, it can lead to all sorts of things like bone diseases in particular. So rickets or osteomalacia children get rickets and osteomalacia in adults. But if you have too much, it will damage your skin cells and it can deplete things, especially in children, folic acid, which is necessary for DNA synthesis. And you can have all sorts of neural diseases from a lack of folic acid and a lack of too much UV radiation can deplete your folic acid levels and cause neural damage. So you want enough, but you don't want too much. So how does this relate to skin color? Well, your skin's pigmentation is a natural sunscreen. And so I obviously had ancestors who typically lived in very northerly latitudes. And so my ancestors lived in a place where UV radiation was low leveled. So they needed as much sunlight as they possibly could get. And it was a positive adaptation to have light skin in that sense. But someone who comes from a place closer to the equator is going to have much higher levels of UV radiation, and you want to have nature's sunscreen, that is to say, melanin in your skin, which is a way to combat too much UV radiation. So in places where high UV radiation is, you have darker skin, and low radiation, you have UV radiation, you have lighter skin. And that's really all it is. But think about, if this is the major thing for racial categories, think about how absurd the next topic is going to be if we were to think of a similar sort of adaptation being our justification for grouping people. We just talked about latitudes. Let's talk about altitudes. Humans that live in high altitudes have to face lower oxygen levels, and you can have hypoxia. If I were to go to the Andes Mountains or the Himalayas and spend a few days, I would start to get altitude sickness. I've had altitude sickness before. It's not fun. I didn't grow up in the mountains, and I don't come from a family that has for generations lived in high places. But Tibetans and Andeans actually, especially over years, actually have larger lung capacity. Peruvian Andean groups have thicker chests and larger lungs, which means that they can actually draw in more oxygen with each breath, and they're able to exist more comfortably at those altitudes. So in principle, what size your lungs are is just as valid of a racial category as your skin color. One is latitude, one is altitude. And they're just adaptations for different localized environmental factors. But you don't go down the street and say, that person's got big lungs, they must be an Andean or a Tibetan or something like that, a Himalayan. But it's just a localized adaptation for differing environmental factors. Now, we all need to have nutrition, and there's a basic metabolic requirement that we all have, and that's a minimum amount of energy that you need to survive, grow, and reproduce. And your total daily energy expenditure is relative to your activity levels and your individual requirements, your size and that sort of thing. So it's generally thought that about 2,000 calories per day is the minimum that you require to be healthy. But that's an average. Everybody's bodies are different. But it's important that it's not just about energy. It's not just about calories. Calories are what we call macronutrients, which are your fuel, right? That's what gets you up and start moving. Carbohydrates, proteins, fats, that sort of a thing. But as we saw in previous chapters, your cells also need micronutrients. These are vitamins and minerals that your little triplet DNA codes tell your body to create these amino acids to do all those important functions in your body. And if you don't get them, this is what we call malnutrition. That's for both macro and micronutrients. All sorts of problems can come from malnutrition. Immune systems can be compromised, which means that parasites and viruses can infect you. Poor environments can lead to things like infectious diseases, especially crowd diseases. We'll look at that in a later chapter. And also your growth, which is genetic, as I said, but it's also strongly influenced by nutrition. So you've got to have the right nutrition to have the right kind of growth. But of course, that doesn't tend to be our problem today in America. It's not so much that we have malnutrition, although there are some food deserts that exist in America, and not everybody has equal access to quality nutrition. But what we tend to do today is we have such an abundance that we don't know when to stop. And we tend to take in more calories and exercise less in the United States, and we actually are facing an obesity epidemic. And it's not just us. We've been exporting this to other countries. Places like Mauritius is newly a fairly newly westernized country. And what's the first thing they do? They start importing the so-called Western diet. And they're one of the highest rates of increase in obesity in the world. That's not to say that we don't have huge numbers of obesity in America. About 50% of adults and 20% of children are considered overweight in America. But we're exporting this lifestyle and this diet to other countries. And the consequences can be dire. Things like that are associated with obesity are high blood pressure, high cholesterol, diabetes. And so we need to be careful today as humans that we have an abundance that we didn't evolve into, right? So for most of human history, we were struggling to get enough nutrition. And now we produce our food and we are struggling to deal with the fact that we get too much nutrition. We'll come back to some of these subjects in later chapters when we look at the development of our species through time. One final thing before we finish this, though. As I mentioned before, we're going to need to look at the fossil record is really the only evidence we have of our species in the past. And it's an imperfect data set that is lacking some things. But if you know what you're looking for, it tells you more than you might first think. Like I said, there's no soft tissue that survives from 1 million years ago. That just doesn't exist. We have the casts, the fossils of bones, but a trained researcher can actually tell what the soft tissue was doing on those bones and repetitive motions, because skeletons also adapt. Skeletons aren't made of metal, they're not just manufactured, they grow in accordance to activities. And so the bones change their size and their shape as adaptations to forces that are exerted on them. So your bones are also, the product of your genes telling you to make those bones. But there are what are called osteoblasts and osteoclasts, which are an osteoblast is if you're doing a repeated motion over and over and over in one direction, your bone will grow in a way that actually gives you reinforcement to resist that pressure that you're putting on it. So if you're doing one thing over and over, one kind of activity over and over and over again, your bone's going to get bigger in that direction that makes it more resilient and more resistant. But it's got to take that material from someplace else, and so that's what is an osteoclast. So an osteoblast is the buildup, and an osteoblast is the buildup in one direction, and where it takes it from, where you're not using that bone or you don't have as much stress, that's reabsorbed, unused bone gets taken away from that place, and that's called an osteoclast. And also, your bone density can also build up in that respect as well. So you can actually get thicker, denser bones through activity. And so physical anthropologists that look at fossils from the past can tell a lot about actually activities that people did just by looking at the impressions of the bones that we find. Okay, I'll see you next time.